So we're going to prove this trigonometric identity here. I haven't looked at it yet on purpose because I don't know, if it happens that I run into some difficulties, I want you to see the difficulties I run into because there's no rule book when solving these. Usually intuition, experience are your guide. So I usually suggest that you start off with the more complicated side. In this case, I guess you could toss a coin, but my intuition tells me that the left-hand side might be a more instructive place to start. So let's start with left side, ls, and I know that's equal to tan theta plus cotan theta, or cotangent theta. And remember, I want to get this into a product because I want to get, what's on the right-hand side there. And it's the product of two trig functions. I don't know. You know what? Let me maybe break this down into its ratio. I have sine theta here. Okay, I know that tan theta is equal to sine theta over cos theta. And cotangent is cos theta all over sine theta. I guess the idea here is that because I have them as fractions, I can now combine them together over a common denominator. And in this case, my common denominator is going to be cos times sine. So I'm going to multiply this side, this fraction by sine theta, both top and bottom. And the other side, I'm going to multiply top and bottom by cosine theta. Okay. What I end up with is sine squared theta all over here. I get cos theta sine theta plus I have cos squared theta, and that's also all over the same thing, which I'll just copy from here and paste it over here. Now this is looking good because I know that sine squared theta plus cos squared theta is equal to 1. So I'll just do the intermittent step. And you know what, I'll just move my work over for the time being. That way I have a little bit more space. I know that this is going to be equal to 1 over, same thing again, cos and sine, product. And that looks good because remember, secant over here is 1 over cos. Cosecant is 1 over sine. I mean, I basically have that over here. I just have to separate this fraction into its two parts, as a product. And I end up with secant theta times cosecant theta. And that completes our proof of this trigonometric identity. Again, I'm going at this blindly. I have no idea where to start. It looks like it works out. Hopefully in my next example I will make a mistake somewhere, so you can just see how I get back on track.